Let f at x equals x squared plus 6x plus 1. And let R denote the set of the points x, y in the coordinate plane such that fx plus f at y is less than 0, and f at x minus f at y is less than 0. The area of R is closest to. So let's work with these two. We have f at x plus f at y is less than or equal to 0. So f at x is x squared plus 6x plus 1 according to the question, and therefore right here, and therefore f at y would be y squared plus 6y plus 1, and this is all less than or equal to 0. So this looks like, it looks like probably a circle. So x squared plus 6x, if you were to take half of that and square it, if you complete the square, you get 9. And very similarly, y squared plus 6y, if you complete the square, you get 9. And that's 18, but we only have 2, so we have to minus 16. So this becomes x plus 3 squared plus y plus 3 squared is less than or equal to 16. Okay? So that is a circle. This is the equation of a circle, basically. Now let's deal with this guy right here. So we have f at x minus f at y is less than or equal to 0. So that means x squared plus 6x plus 1 minus y squared minus 6y minus 1 is less than or equal to 0. And let's see, this becomes x squared minus y squared plus 6x minus 6y, because the 1's cancel, is less than 0. And I believe the factoring will help us, x minus y, x plus y. Factor out a 6, and this gives x minus y like that. Factor the x minus y, and you'll get x plus y plus 6, like that. And I think that is about as far as we can go there. So now we have to plot these on a graph. So let's make a graph. So we've got like that, x and y. And the first one is basically a circle, and it has a center of minus 3, and it has a radius of 4, approximately like that. And now we have to concentrate on this right here. X minus y times x plus y plus 6 is less than or equal to 0. So this is true in two possible ways. The first way is if x minus y is less than or equal to 0, and the other guy is greater, like that. Okay, so that means that x is less than or equal to y, and x plus y plus 6 greater than 0. We can isolate for one variable here. Let's isolate for y. Y is greater than minus x minus 6. Okay, so these are obviously lines, so we have to plot them. The first one is the line x equals y, right? X equals y is just basically a line that goes, like that. That's the first one, x equals y. Okay, the next one is a line y is equal to minus x minus 6. So y equals minus x minus 6, so I'll plot that one. So when I plot this line here, this guy, it's going to be something like this, approximately. Something like that. So now we have to figure out what are the regions in this diagram that we are interested in. Because if you read the question, R denotes the set of points in the coordinate for which these are all true. So the area of R is closest to. So we have to figure out what is that region. The first equation led us to this, which is the circle. So that whole region right there, inside that, because it's not equal to, it's not just equal to, it's less than. So all the points inside that circle, okay, are part of R, the range, or the basically the set of points that we are trying to identify. So that takes care of the first one. Now the second one, which is right here, gave us another set of points. It gave us case 1, and then it gave us case 2, which is as follows. Case 2 is if x minus y is greater than or equal to 0, and x plus y plus 6 is less than or equal to 0. So that means x is greater than y, and y is less than or equal to minus x minus 6. Okay? So the first scenario, this guy right here, if you were to combine these two, where on the graph would that be? Case 1. X is less than y, and y is greater than minus x minus 6. And I'll label that line y is equal to minus x minus 6. That is this region right here. This region right here. In that region, x is less than or equal to y, and y is greater than or equal to minus x minus 6. Now case 2, x is greater than or equal to y, and y is less than minus x minus 6. Where is it on this diagram? It's this region right here, that region. So the area of those regions that I just shaded in orange is what we have to figure out. So how do we do that? I hope you notice one thing here. Y is equal to x. What is the slope of this line? Well, it's like 1x, right? And the lines are always written in the form y is equal to mx plus b, where m is the slope. So the slope of this line right here is 1, because m in this case is 1. What about this line here? What is the slope? It's like y is equal to minus 1 x minus 6, correct? So the slope of this line is negative 1. So that means you have two lines. One has a slope of 1, the other has a slope of negative 1. Therefore, those two lines are perpendicular. And if they are perpendicular, it means that this is a right angle. Okay? So that allows us to figure out the area of those shaded regions. How? Area of a circle, pi r squared, you know that. If that is a right angle, that's 90 degrees. So it's basically a quarter of the circle, because the full all the way around is 360. 90 degrees divided by 360 is a quarter. And we've got two of those, right? We've got two of those regions. And this diagram, sorry, it's not drawn perfectly to scale, but you get it by now. So that takes care of the first region. And then the second region, not reason, would be the exact same formula. We have a 90-degree angle over 360, and then pi r squared. So here we go. 90 over 360 is 1/4. Pi r. What is r? What is the radius of the circle? It was 4. So 4 squared, again, 1/4 pi 4 squared. So this gives us 16 pi over 4 plus 16 pi over 4. And that's 4 pi plus 4 pi, which is 8 pi. So 8 pi is the answer. The area of R is closest to, okay, they want an actual number. All right, no problem. 8 pi is what? 8 times 3.14. and that is approximately 25.1. Yeah, 25.1. So 25.1, area of R is closest to 25. So number 25 is 25, and that's choice